Let's kick off this project by creating the most fundamental unit of the blockchain that will power our eventual cryptocurrency, the block. To build a chain of blocks, well, we need the blocks themselves. At the core, blocks consist of four fundamental pieces of data. First, we give blocks a timestamp to record when they were created. The timestamp will be created with the JavaScript date object, which allows us to specify unique times down to the millisecond. Second, we give the blocks an attribute which we'll call lastHash, which is the hash of the block that came before it. Remember that the hash is a unique value for a block that is generated based on a combination of all of its unique data. Third, we have the hash for the new block, which is generated from its own unique data. And fourth, we have the data that we want to store within the block, whether that's a string, an array of numbers, or an entire JavaScript object that represents something big like transactions or any other kind of data. With that in mind, let's create our first class in the project, a JavaScript class called block. So go ahead and switch to your code editor and have your project open for sfchain. Your package.json file should look something like this, with the dev dependency for NodeMon so far. In this project, let's create a new file that we're going to use to hold our block class, which is block.js. And for this project, we're going to use the object-oriented programming style. So in this style, we create classes for objects, so that way we can make instances of those objects. And then we can build programs based on how those objects interact with each other. Now in this file, let's create a new ES6.js class with the class keyword. And then we'll call this class block. And then have a pair of curly braces for the body of the class. Now in this class, we're going to give this block a constructor. And this is a special function, which is another main feature in most object-oriented programming implementations. It's a special function which helps us define the unique attributes for any instance of this class. In the constructor, we attach attributes to this class and then assign them to the unique arguments that are passed to the constructor function itself. For the arguments of this constructor, recall what attributes a block needs. Well, it needs the timestamp. So let's have that as our first argument. Then it needs the hash of the last block, which we'll call lastHash. Then it needs its own hash, so have a hash argument as well. And then we also have the data that we want to store within the block. And now within the constructor, we're going to take the input that is given to the constructor and then bind it to this class by using the this object. So we'll say this.timestamp is equal to the inputted timestamp. And this is an object which represents a unique instance of this actual class. So since we have this class that is the block now, we're going to make a new block in the future. And when we make that new block, we'll give that new block certain timestamp, lastHash, and hash and data information. And when we make that block, this object will take that inputted timestamp and bind it to a property on this block called timestamp as well. So let's do the same thing with the lastHash, as well as our hash, as well as our data finally. Great. We now have a unique constructor for the block. Another key characteristic of object-oriented programming are toString functions for classes. So let's add a toString for this class. And the toString is usually used in debugging, which we'll do a little bit of throughout this course as we build the project. So it'll be helpful when you have the toString function, which returns what this specific instance of the class actually looks like. So within our toString function, we're going to return a template string, which is just like a regular string, except we can have ES6 interpolation within it, meaning we can display variable data within it very quickly and insert that. So notice that these are backticks and not the regular single quote. So for a template string, use the backtick key right next to the one key on the keyboard. So again, these are diagonal ticks, not actual single quotes. And now within this string, will return, well, that this is a block. So when we call toString, it'll say that it's at least a block. So have block on the first line alongside the backtick. And then for every piece of relevant data, first we'll have the timestamp. And then this is a hard-coded string, but now we can insert the unique timestamp of this instance within a pair of curly braces and a $sign right before with this .timestamp. Likewise, let's print out the last hash. And then for this one, we're going to print out this .last hash. Same thing for the hash, and to keep things organized, how about aligning the colons over there? Again, $sign curly brace this .hash. And then we're going to have our data over here. Again, keep it aligned. And we're going to insert this .data. And then this final backtick can be on the same line as the last data line. And finally, we have our semicolon. Now, one thing to note is that these hash values will be pretty long. They'll be about 32 characters normally. So what we can do to limit the actual output of those hash values to make sure that they're not so giant when they're printed to the command line is to use a substring function on each of them. And the substring function will take only part of the string and return that. So we'll take from 0 to 10. So that way only 10 of the characters are printed for the hash. And that should be more than enough characters to see unique hashes for the blocks that we'll create. We'll do the same thing for the regular hash of the block. Great. For the last step, let's make sure that this block class is shared from our file by exporting it as a module that can be included with other files. So the syntax for that in Node is module.exports, and then we set it equal to the object that we want to share, which in this case is our block class. Awesome. So that sets up our very first block class. Now, it would be nice if we had a way to test it and make sure it works. So for now, let's make a new file purely for development purposes called dev-test.js. That's dev-test.js. And the goal of this file will be to explore that block class. So first up, if we're going to explore the block class, well, we need to get access to it within this file. So let's make a block constant, and then we'll set it equal to requiring the module that we exported from our block class, which we use the require syntax for. And notice the /, this is referencing the local block file that we just created. And now that we have this block class, we can make an instance of the block by using the new keyword. So notice that the actual variable for our instance is lowercase. Then we use the new keyword, and then we use the uppercase block class. And then we have our pair of parentheses over here, which is the actual parentheses that we use to give data to the block constructor. So we need to give it some data. So how about some fake values like foo, bar, zoo, and baz? So respectively, the foo will be the timestamp, the bar will be the last hash, zoo will be the hash, and baz will be the data of this block. Now, those values don't really make sense, but the goal is for right now to see our toString function. So let's console.log our block.toString. So this will have the effect of returning the string representation of this block and then logging it to the console. Perfect. Finally, let's add a script to our package.json file, which will allow us to immediately run this dev test file. So in package.json, go to the script section over here. Right now, there's one default one for test, which actually won't do anything yet, but we will have dev-test. And for this, we'll call the nodemon runner that we installed previously and tell it to run the dev test script. With that, we can now open this up in our command line, or rather run the script in our command line with npm run dev-test. And then this fires the file. And look at that, we have one block whose timestamp is foo, whose last hash is bar, whose hash is zoo, and whose data is baz. Excellent. So we see that we have our block right there on the console. We've now completed the most basic unit of our overall blockchain-based project, the block itself. So let's move on and work on what is called the Genesis block next.